Well, hello, it's Peter Emmanuel here, and in this video we are going to be talking about what is called integration by parts. Now, I introduced you to integration in the previous video as the opposite of differentiation, where I gave you the rule for integration to be for a function of x to be x n plus 1 all over n plus 1. And right now I'm going to introduce you to integration by parts, which is going to be used when we're talking about the product, that when we're actually finding the integral of the product of two functions. Now, the integration by parts is simply, it has a formula which is simply gotten from integrating product rule, and product rule is the formula for finding the derivative of the product of two functions. Now, when we integrate that formula, we can be able to find the integral of the product of two functions. Okay, so let's get straight to business. Now, product rule simply is the y, the x when I'm looking for the product of two values, let's say u and v. That's assuming I have my f of my y, that to be equal to u dot v, and I'm asked to differentiate it. Therefore, dy dx is the same thing as du dot v over dx is going to give me the value of my u multiplied by the derivative of my v plus the value of my v multiplied by the derivative of my u. Okay, so if I'm to integrate this, it's simply going to give me that integrating the whole of this is simply going to give me integral of u multiplied by, here I have dv over dx, treating this as a whole value, plus the integral of v du over dx, treating this as a whole value. Now, dx cancels the x, dx cancels the x, so I'm left with, here this gives me uv to be equal to integral of u dot dv plus integral of v dot du. So the x cancels the x, so this gives me my uv to be equal to integral of u dv plus the integral of v du. So at times you normally move one of these to the other side and bring the other, so I can still write the equation as the integral of v du to be equal to uv minus integral of u dv. Can also write it as the integral of u dv to be equal to uv minus the integral of v du. Any of these forms is still okay, but this is the easiest way to understand. Okay, so let's apply this here to solve some